Hello everyone, welcome to Module 1. This is section 1.4, which is on dividing whole numbers. So again, I want to start by mentioning some properties of division, and then we will review how we actually perform the algorithm of long division to divide numbers. So let's start with some properties. So the first property says if I take any whole number a and divide it by itself, right, divided by a, or I could write this like this, a over a. When I write a fraction, that also means division. That's equal to 1 as long as a is not 0. Right, we'll talk about what happens if a is equal to 0. If that denominator is 0, that's not something we can do in mathematics. It's called undefined, but we'll mention that in a little bit. But anything else, if I divide it by itself, it's equal to 1. Like 17 divided by 17 will be 1. A million divided by a million would equal 1, and so on. Second property, if I take any whole number, and really this is true for any real number, but right now we're just dealing with whole numbers, and divide by 1, which I could also write like this, that's just itself, right? So negative 17 divided by 1 is negative 17. 18 divided by 1 is 18. 0 divided by 1 is still 0. Okay. Let's emphasize that in this next property. So if I take 0 and divide it by any number, or I could write it like this, that is equal to 0 as long as a itself is not 0. So I'll say if a is not equal to 0. So again, 0 divided by 27 is 0. 0 divided by 1 million is 0. As long as the denominator is not 0, then that answer is going to be 0. And of course, if we go the other way, let's say I take any whole number and divide by 0, which I can write like this. This is something that we can't do in mathematics. You cannot divide by 0. It doesn't make sense, right, to say how many times 0 went into something. So we cannot divide by 0. So what we say is that this operation is undefined. And by the way, this is true for any a, even if a itself is 0. So here, let's do a couple of examples here. Let's say I have 33 divided by 33. So that would be the first property, right? Anything divided by itself is equal to 1. If I have 21 divided by 1, that would be an example of the second property, right? Anything divided by 1 is itself, so this would equal 21. If I have 0, let's say divided by 156, well, 0 divided by anything, as long as the denominator itself is not 0, is equal to 0. So that's going to be 0. But if I have a 0 in the denominator, that's going to be undefined. Even if you have this, right? If I have 0 over 0, you might ask, well, which one wins out, right? Could this be, I mean, this is something over itself, so you might think it's 1. Or since the 0 is in the numerator, you might think it's 0. But it's really this 0 in the denominator that tells you we can't do that, right? So this is going to be undefined as well. You can never have a 0 in the denominator. So 0 divided by 0 would also be undefined. Okay, what I want to do next is review the algorithm for performing long division. Okay, so let's say I have, let's say that I want to divide 1355 divided by 5. Okay, so first of all, these numbers have names. This first number is called the dividend. The number that you're dividing by is called the divisor. And then the answer is going to be the quotient. So the answer to a division problem is a quotient, just like the answer to a multiplication, remember, is a product, or the answer to an addition problem is a sum. For a division problem, it's going to be a quotient. Okay, so how do we do this? Well, we usually use the long division algorithm, right? So I have my my dividend, I write inside the division symbol. And then divisor goes on the outside, right? That's important. Make sure you have that correct. The dividend goes on the inside of the division symbol. The divisor goes on the outside. Now, we want to figure out how many times 5 goes into 1,355. Okay, so to do this, we start at the left-hand side of the number. And we first ask, does 5 go into 1? No, 5 doesn't go into 1, right? 1 is smaller than 5. So then I consider the first two numbers, the 13. Does 5 go into 13? Yes, it goes in 2 times, right? So what I do is I write a 2 over the 3 here. Now, really what you're saying is, because the 3 is in the hundredths place, you're saying that 5 goes into that, the original number, 1355, 200 times. Actually, let me write that down for now. Let me sort of explain why this works. So because I put a 2 here, really what I mean is it goes in 200 times. So now if I multiply the 200 times the 5, I'm going to get 1,000. And when I subtract that, because we already handled 1,000, right? I'm going to have 355. Then I ask, well, how many times does 5 go into 3? Well, it doesn't go into 3, so I have to go to 35. How many times does 5 go into 35? It goes in 7 times. But again, because that 5 is in the tens place, really what I'm saying is 5 goes in 70 times. Okay, and then when I multiply 70 times 5, I get 350. Subtract again. All I have left now is a 5 here. How many times does 5 go into 5? It goes in once, and since that's in the ones position, this is just going to be a 1 here. Okay, so really what we've shown is that it goes in first 200 times, then 70, then 1. If I add those together, that's got to be my answer, which is 271. Now, do we ever do the problem exactly like this? No, we always compress all of our work. So let me show you this again and how I'd actually do the algorithm. I just wanted to show you why this works. So let's do the problem again. So it's 1355 divided by 5. So I would just say, okay, 5. Does it go into 1? No. Does it go into 13? Yes, it goes in 2 times. So instead of writing 200, I'm just going to write the 2 there above the 3, even though it really means 200. Now I multiply 2 times 5, and I get 10, and I write that below the 13. Again, that really means 1,000, right? Because you're in, the 1 is in the thousands place, the 0 is in the hundreds place. So that really means 1,000. But you don't ever write the 2 zeros here. I don't ever write the 2 zeros here. So I just write the 10. I subtract. 13 minus 10 is 3. And then instead of bringing down the entire number, the entire thing left over, I just bring down the next digit. So that 5 comes down right there. So 35. Now I can ask, how many times does 5 go into 35? Well, it goes in 7 times. So I write the 7 in the tens place here. 7 times 5, I multiply. 7 times 5 is 35. I subtract, and then bring down the next digit. And then finally, I can ask, how many times does 5 go into 5? It goes in once, so I write 1 in the ones place. I multiply. Now write 1 times 5. That's going to give me 5. Subtract. And then this would normally be my remainder, but my remainder in this case is 0. So that means 5 goes into 1,355 exactly 271 times. Okay, so this answer would be 271. All right, so once you understand the long division algorithm, that is the easiest way to do these problems, to do the division. So here, let's do some more practice here. Let's say I want to divide 7,500 divided by 300. So how many times does 300 go into 7,500? So I write out my problem. Here's my division symbol. Make sure the 7,500, right, 7,500 goes on the inside. The divisor, 300, is on the outside. And now you would ask, right, how many times does 300 go into 7? It doesn't. So then I include the next digit. How many times does 300 go into 75? It doesn't, right? 75 is less than 300. So then include the next one. How many times does 300 go into 750? Well, that's going to be twice, right? Because that will give you 600. 3 times would be too much. It'll be 900. So this is going to be twice. Sometimes you have to go over on the side and try and figure this out. Sometimes you have to multiply things out to figure out how many times. It's not always obvious. So now when I multiply the 2 by the 300, I'm going to get what? I'll have 0, 0, 6, right? So 600. I subtract. So this will be 0, 5, 1. And then I bring down the next digit, which is a 0. And then I can ask, how many times does 300 go into 1,500? It turns out it's 5 times. And now when I multiply the 5 times the 300, I'm going to get exactly 1,500. So I subtract, and my remainder is 0. So it goes in exactly 25 times. So this answer would be 25. Okay, here's another example. Let's say I want to divide 31,031 divided by 13. Okay, so 31,031, I want to divide that by 13. So again, look at the first digit. Does 13 go into 3? No, 3 is smaller than 13, right? So then I have to go to the the next digit over. So 31. Does 13 go into 31? Yes, and again, there's a lot of like mental math that you have to do here. If you have to, you can do it on the side as well. But if you think about it, right, 13 times 2 is going to be 26. 13 times 3 is 39, so that's too big. So it looks like it goes in 2 times. And sometimes you have to go on the side and do this math. Sometimes it's not obvious. You might have to work it out. Okay, so now I can multiply 2 times 13. That's going to give me the 26. I'm going to subtract, right? So I need to borrow. That's a 2. I borrowed basically a 10, so I can put a 1 there. 11 minus 6 is 5. And then I bring down the next digit. So this is a 0 here. 13 into 50. Let's see. It looks like that will be 3 times. So then if I multiply 3 times 13, I'm going to get 39. So now I would subtract, so I have to borrow again here. This is 1, 1, and then bring down the next digit. This will be 3. Okay, 13 into 113. Again, let's see. Maybe 8, maybe 9. Let's work it out on the side here. So 13 times 8, what does that give? So that'll be 24. So it looks like 104. I guess that's right? Because if I do 9, it's going to be too big. Let's do it to make sure. So if I do 13 times 9, that's 27. So carry the 2. And then 9 times 1 is 9 plus 2 is 117. That's too big. So it looks like it's 8 times. So this will be 8 times. So when I multiply 8 times 13, that was the 104. Now, if I subtract, right, so again, I have to borrow. 13 minus 4 is 9. And I can bring down the last digit, so the 1 here. And then 13 goes into 91. I believe it's 7 times. Let's try that. So 7. So 7 times 3 is 21, carry the 2, and then 7 times 1 plus 2 is 9. Yeah, that works. And then my remainder is 0 in this case. So it looks like the answer is going to be 2,389. Okay, well, what if we have a remainder, right? Let's do a couple where we have a remainder. Let's say I want to divide 206 divided by 45. Okay, so 206 divided by 45. All right, well, this 45 definitely doesn't go into 2, right? It doesn't even go into 20. 20 is still too small, so I'm going to have to use the full 206. It looks like, let's see, if it was like 50, right? 50 times 4 would be 200, maybe 4 times. Let's try that. So in the ones place now, right, I put the 4, I multiply. 4 times 5 is 20, and then 4 times 4 plus 2 is 18. Subtract, so this is going to be 6, and then I need to borrow here, and that's going to be 2. And actually, I can't, 45 doesn't go into 26, right? So 26 is my remainder. So then I would write this as, this is equal to 4 with a remainder of 26. Okay, here's another one. Let's say I want to divide 13,502 divided by 97. Okay, so I'll do this. Write it out here as a long division problem. Okay, so now I ask myself, does 97 go into 13? No, I need to include the next digit. So does 97 go into 135? Yes, and I guess it only goes in once, right? Because 2 times would be almost 200, so this would be just once. I multiply 1 times 97, well, that's just 97. And then subtract. So I need to borrow here, right? So 15 minus 7 is 8. 2 minus 9 I can't do, but I can borrow. So 12 minus 9 is 3. And then I bring down the next digit, a 0 here. Okay, 97 into 380. Again, 4 times is going to be just about 400. So it looks like it'll only be 3 times. So it looks like 97 goes in 3 times. So if I multiply 3 times 7 is 21. 3 times 9 is 27 plus 2 is 29. Then I subtract. So I need to borrow, right, or decompose it. 10 minus 1 is 9. I need to borrow again, right? Make this a 17. 17 minus 9 is 8. And then I bring down the next digit to 2. So 892. And then 97 to 892, that probably is 9, right? Because it's going to be less than 900. Let's try 9. So 9 times 7 is 63, right? Carry a 6 here, and then 9 times 9 is 81 plus 6 is 87. Yeah, so that works. So now if I subtract, again, I have to borrow, right? So 12 minus 3 is 9, and then 8 minus 7 is 1. So it looks like my answer is going to be 139, right, with a remainder of 19. So that would be the answer for this particular problem. And again, it just requires practice, right? You probably haven't done long division in a while, so it's going to require a little bit of practice. Some of it is like mentally trying to figure out the number that goes in, but you can always multiply, right? You can do the work on the side and multiply to make sure that you have the correct value. Okay, let's just do a few examples from your Maya Open Math homework. So this first one, we want to divide 832 divided by 52. Okay, so 52 doesn't go into 8, but it will go into 83, right? It'll go into 83 once. Then I'll multiply 1 times 52 is 52. I'll subtract. So 3 minus 2 is 1. 8 minus 5 is 3. And then I can bring down the 2 here. And then 52 into 312, it looks like that'll probably be 6 times, right? So let's try 6. 6 times 2 is 12. 6 times 5 is 30, plus 1 is 31. Yep, and the remainder is 0, right? So this is going to equal 16, exactly 16. Right, and then the next one, we have 3726 divided by 81. Okay, so does 81 go into 37? No, so I have to include the 2 here, right? So I want to ask, how many times does 81 go into 372? So again, if you think about this, right? 8 times, let's see. Basically, 80 times 5 would be 400, right? That's too big, so it's probably 4 times. Again, if you have to, go over to the side here, right? So if I do 81, right? If I do times 5, that's too big because I'm going to get 405. But if I do times 4, that should be fine. So 4 and then 8 times 4 is 32. So 324. Yeah, that works. So this looks like it's going to be 4 times. So again, I'm going to get 324. Now I subtract. So I need to borrow. 12 minus 4 is 8. 6 minus 2 is 4. Bring down the next digit, which is 6. And then 81 into 486. Maybe, let's see. It looks like it'll be 6, right? Exactly 6 times. Let's try 6. So now if I multiply 6 times 1 is 6. 6 times 8 is 48. Yep, and my remainder is 0. So this is exactly 46 times. Okay, let's do one last question. So this is a word problem where they say Karen is planning to drive 3,051 miles on a road trip. If she drives 339 miles a day, so every day, 339 miles, how many days will it take to complete the trip? So basically, this is going to be a division problem in disguise, right? If the total distance is 3,051 miles, here, let me draw this out. Let's say this is the total distance. So this is 3,051 miles. And each day, she's able to drive 339, right? And that's like day 1. And then 339 miles. This really has units of miles. Day 2, and so on. And I want to figure out how many days it takes to complete the trip. Well, this is nothing more than a division problem, right? So I want to divide 3,051 divided by 339. Okay, so let's do that. So long division. So 339 doesn't go into 3, doesn't go into 30. Actually, it doesn't even go into 305. So we're going to have to figure out how many times it goes into the entire number. You might have to try a couple of different values here on the side. It turns out, I believe it's going to be 9. Let's try 9. But you might have to work out a few values to figure this out. So let's try 9 first. So 9 times 9 is 81. 9 times 3 is 27 plus 8, right, which is 35. And then 9 times 3 is 27 plus 3, which is 30. Yeah, that does work. And in fact, the remainder is 0. So actually, it goes in exactly 9 times, so that's going to be our answer, right? Our answer is going to be 9 days. It'll take 9 days to complete this trip. Okay, but it was nothing more than really a division problem in disguise. Okay, great. So that's it for division of whole numbers. Thanks.